Good morning, everyone. Today, we will discuss some fundamental concepts in thermodynamics that form the basis of understanding various thermal systems. The topics we will cover include state, process, and path in thermodynamics, along with types of thermodynamic process such as the cyclic process, Quasi equilibrium process, and the distinction between reversible and irreversible process. These concepts are crucial for analyzing and designing thermodynamic systems like engines, refrigerators, and power plants. So let's begin. First, let's understand what we mean by the state of a system in thermodynamics. In simple terms, a state refers to the specific condition of a system at a particular moment. This condition is characterized by certain properties such as temperature, pressure, and volume. For example, consider a gas inside a cylinder. If the gas is at a pressure of 100 kilopascal, a temperature of 300 Kelvin, and occupies a volume of 1 cubic meter, then we say that the gas is in a definite or a defined thermodynamic state. These properties are important because they provide a complete description of the system at any given time. If any of these properties change, the state of the system also changes. In thermodynamics, we always define the state of a system before analyzing any changes or process it undergoes. With this understanding, now let's move on to next concept, that is process. Now that we know what a state is, let's talk about process. A process in thermodynamics refers to the transition of a system from one state to another due to changes in properties like pressure, temperature, or volume. For example, if we heat a gas in a piston cylinder system, the gas expands, increasing its temperature and pressure. This means that the gas is transiting from its initial state to a new state. And this transition is what we call the process. A process can be fast or slow. The process can be reversible as well as irreversible and can follow different paths depending on the external condition applied to the system. This brings us to one more new concept which is called as path. And in the next slide, we are going to see this path in thermodynamics. The path of a process refers to the trajectory or series of intermediate states that a system follows when transiting from one state to another. Imagine you are traveling from one city to another. There can be multiple routes to reach your destination, and each route represents a different path. Similarly, in thermodynamics, a system can go from an initial state to final state following different paths depending on how the process occurs. For example, if we plot the pressure and volume of a gas on a PV diagram, we can visualize different paths the system that takes. One path might be an isothermal process where temperature remains constant, while another part might be an adiabatic process where no heat is exchanged. Understanding the path of a process helps us to analyze how energy is transferred and work is done by or on the system. Now, let's move to a new important type of a process called the cyclic process. Coming on to the new concept, as we discussed earlier, cyclic process. A cyclic process occurs when a system undergoes a series of processes and then returns to its initial state. For example, consider a heat engine, such as internal combustion engine in a car. The engine takes in fuel, burns it to produce power, and then expels waste gases, and completing a cycle. At the end of each cycle, the system returns to its initial or original starting condition. A key characteristics of a cyclic process is that the total change in internal energy over one complete cycle is zero. This is because the system ends up in the same state where it started, meaning that whatever energy which was added to the system has also been removed from the system. Cyclic processes are fundamental in designing power plants, refrigerators, and air conditioning systems. Let's now discuss another special type of process, the quasi-equilibrium process. A quasi-equilibrium process is an idealized process or an ideal process in which changes occurs extremely slow, allowing the system to remain in equilibrium at all the times. Imagine a gas in a piston, and this gas we are compressing very slowly. Because the process is very slow and gradual, the gas remains uniform in temperature and pressure at every moment. This is what we call a quasi-equilibrium process. Now, such processes are important in engineering because they allow the precise analysis and control. In many cases, we assume process to be quasi-equilibrium to simplify the calculation process or the analysis process. Even though real-world processes are often not perfectly slow or uniform. Now let's talk about two important classifications of a process, which are reversible and irreversible process. Now we will see reversible and irreversible process. First, let's discuss reversible process. A reversible process is one that can be reversed without causing any change in both the system and its surrounding. This means that the system can go back to its initial state with no net energy loss. For a process to be truly reversible, it must occur under ideal conditions, meaning there should be no friction, no turbulence, and no energy dissipation. An example of a reversible process is the slow control compression or expansion of a gas where every intermediate state is in equilibrium. However, in reality, most processes are irreversible. Coming on to the irreversible process, an irreversible process is one that cannot be reversed without causing changes in the surrounding. This process involves factors like friction, turbulence, heat loss, or mixing of substances, which prevents the system from returning to its original state or original condition. For example, when you let air escape from a balloon, it expands rapidly and mixes with the surrounding air. This process is irreversible because the air cannot be recollected back into the balloon without the external intervention. Another example of irreversible process includes heat transfer due to temperature difference, free expansion of gases, and chemical reactions. Most real-world processes are irreversible, but understanding reversible process helps us to design more efficient energy systems. Now, let's summarize today's session. Today, we have seen in this lecture the first important concept, the state of a system, which is defined by its properties such as pressure, temperature, and volume. After that, we have seen important concept known as process. A process is a transition from one state to another. The third important concept, path. The path describes how a process occurs or how the process happens. Next important concept was the cyclic process. The cyclic process returns to its original state when no net change in internal energy occurs. We have seen a quasi-equilibrium process that happens very slowly, and all the components or system properties are at equilibrium with the surrounding. Then we have seen the reversible and irreversible process. Reversible process can be undone without any net change, whereas irreversible process involves dissipation and cannot be reversed naturally. These concepts are the foundation of thermodynamics and are crucial in designing engines, refrigerators, and other thermal systems. Thank you for your attention. I will be happy to take any questions if you have. Please drop me the mail in this case.